Origami. You might think of paper cranes or a child's pastime, but this ancient art is now a powerful tool for science. It tackles modern problems from tiny medical robots to giant space structures. Origami's potential is vast and unfolding before us. How can folding paper help science? The answer lies in its core principles. The mathematics of folding allows complex transformations. Flat sheets become intricate three-dimensional shapes. This is no longer just artistic expression, it's innovation. Scientists and engineers are taking notice. The future is being meticulously folded. Folding creates specific structures and unique functions. Think of a roadmap. Fold small, unfolds large. Origami harnesses this power on a grand scale. Simple folds lead to complex results. In this exploration, we'll see origami in space travel. We'll learn of its groundbreaking medical uses, discover its impressive engineering feats. This journey showcases human creativity. It reveals how old ideas find new life. Origami is more than just paper. It's shaping our collective future. Let us begin this fascinating exploration together. What is origami? It's the art of paper folding. The word comes from Japanese oru, to fold, and kami, paper. You start with a flat sheet, usually square. No cuts, just carefully placed folds create the shape. It's an art demanding precision and geometric understanding. Origami has deep roots in Japan, starting centuries ago. Early forms had special uses in religious ceremonies and gift wrappings. Over time, it became a popular folk art and educational pastime. Now let's look to the stars. How can this art help us explore space? Rockets have limited cargo space. Scientists dream of deploying large instruments like solar panels and telescope mirrors. Origami offers a clever solution. Fold small, unfold in space. Enter the Miura fold, invented by Koryo Miura, a Japanese astrophysicist. This fold allows large surfaces to be compact. Imagine a vast solar array folded like a road map. In space, it deploys smoothly and reliably. NASA uses this for its satellites today. Origami's cleverness is transforming space exploration. It's a testament to human ingenuity. From ancient art to modern science, origami bridges the gap. It shows how creativity can solve complex problems. The journey of folding is just beginning. Let's continue to explore its potential. The cosmos awaits our folded creations. Origami is making waves in medicine. Doctors need tiny tools for minimally invasive surgery. These tools must enter small incisions or travel through vessels. Origami principles are perfect here. They allow devices to be small and deployable. This helps patients heal faster. Consider origami medical robots, small enough to swallow. Imagine taking one like a tiny pill. These robots travel within the body, navigating to problem areas. They unfold to perform actions, like delivering medicine or surgery. This field is growing rapidly, offering new treatment hopes. Origami also helps create better stents. Stents prop open blocked arteries, vital for heart patients. An origami-inspired stent folds small, expands in place. This restores blood flow, saving lives. Other implants use similar folding ideas. Benefits include less invasive procedures and smaller scars. Recovery times are shorter, with less pain. Origami design tools are precise, improving outcomes. It's folding for better health. A new dimension in medical care. Origami's impact on medicine is profound. It's a quiet revolution in patient care. The future of medicine is being folded. Let's embrace this innovative approach. Engineering loves origami principles. Its concepts are versatile, extending beyond space and medicine. Dynamic structures can adapt, changing shape when needed. This adaptability is useful for diverse applications. Engineers are exploring these possibilities. Consider foldable structures like emergency shelters. After disasters, people need safe housing quickly. Origami shelters pack flat, easy to transport. They assemble fast, providing safety in crises. Even temporary bridges could use folding designs. Robotics is another exciting area for origami. Origami robots change form, moving better. They squeeze through tight spots, then expand for tasks. Imagine a search and rescue robot in earthquake rubble. Its adaptability is key to success. Origami makes robots smarter and more capable. Origami-based designs are lightweight and efficient. They fold compactly, saving space and reducing costs. Deployment is simple and quick. This combination solves modern engineering challenges. It's a new way to build. Nature is the original master of origami. Life uses folding principles constantly. A flower bud unfurls its petals carefully. An insect's wings pack neatly, ready for flight. These are natural marvels of engineering. We learn from nature's folding. A ladybug's wings fold under its shell, ready for action. Plant leaves emerge from buds, expanding for sunlight. Proteins in our cells fold into precise shapes for tasks. This natural ingenuity inspires new materials. Scientists create metamaterials with origami-based structures. These materials have unique abilities like absorbing impacts. Imagine car bumpers that fold for protection, or buildings adapting to withstand earthquakes. Origami is more than art. It's a universal principle. It has vast scientific and technological implications. From medical devices to space structures, folding shapes our universe. It influences our technology profoundly. This ancient art unfolds into a future of innovation. The cosmos loves a good fold.